Stream processing in Kafka using Python. That's what we're going to build today. We're going to build a stream processing app because we've done a few videos. We've done one that writes data into Kafka with Python, one that reads it out using Python. But what if the readers and the writers don't agree? What if the writer is coming from one department in a large company and the readers in another department, and you don't want to have them sitting down in some meeting where they agree what the format's going to be? Can we transform the data coming in before it goes out? Yes, we can. That's one of the bread and butter jobs of stream processing, and we're going to go through it. So we'll do every line of code, chapter markers down below if you want to skip the setup. But if you're still with me, let me set up a project. We've got some weather data we've been playing around with, so I'm going to use that. I'm going to call my stream processor weather processor. I'm going to set up a Python virtual environment. Much bike shedding in the office recently about whether you call your virtual environment env or .env or .vmv. I don't think it matters myself. It's kind of like James Bond actors and Doctor Who actors. The one you first got familiar with is the right one, and the technical arguments don't really play into it. I like env, so that's what I've gone with. Let me set up. Oh, I need a library. There's one library I want for this, and it's called Quick-Streams. Very nice Python stream processing library. And with that, I will edit a main script. And I think for once, I'll set up all my scaffolding at once. Let's get this out of the way. I want logging. I'm going to define a main function, which just does logging.info start. Then I will invoke the ancient Python runes with this incantation. And set up logging.basicconfig level equals debug. And I sometimes think if you chopped my head off, then in the last few moments, my body will be able to write this code just from what's stored in my spinal column. It's a gruesome metaphor, isn't it? Anyway, that should be enough to get us writing some Python code. Let me just check it. I will create another terminal here. Activate my environment, and yeah, okay, that's good. Python ready. So to write a Python stream processing application, I will import application from Quick-Streams, and I will create such an application with, if you've been following this series along, you know how this is going to open. I create a broker address to say, where can I find Kafka on the network? Mine's running locally on 1992. If you're running Kafka locally, chances are it's exactly the same. And for sanity's sake in development time, I'm going to set my log level to debug. Those are the easy ones. Now, next, I want to say, I'm going to do some stream processing work. And there's a topic I'm going to read, and there's probably already some data in there. I think there are a couple of thousand messages in my topic. Yours might have a few thousand or a few million or maybe even a billion messages. Do you want to process all the old ones, or do you just want to start from the new ones? In my case, I want to make sure I've processed every message. So I'm going to start from the earliest possible message when I connect using the curiously named parameter auto offset reset. If you want a full discussion of these particular parameters, have a look at the consumer video we did. I went into that in depth. The other thing you need to do is identify who's connecting. So I could be writing one application that connects and reads from the earliest, completely different application that connects and wants to start reading just from the latest. So I have to identify which application this is with just a unique string. I'll call it weather processor. Any unique string will do, and that will take care of exciting things like load balancing and more mundane things like progress through the topic tracking. With those two set up, that will be enough to start the handshake with Kafka and start doing some work. So what work do we want to do and how do we do it? What we need to do is tap into the data frame API of Quick-Streams with a call to data frame, give it a topic we want to read from, and that will give us a streaming data frame. If you're familiar with NumPy or Pandas or a few libraries like that, this API is going to seem quite similar. It's modeled after those ones. Slightly different because streaming isn't quite the same as like dealing with static tables, but there's a lot of overlap. If you haven't used those, if you've done any functional programming or even any list processing, what we're about to go through will feel familiar. We're going to read stuff from the topic. We're going to teach this API how to deal with one message, and it will magically go off and make it happen to all the messages. So what's our topic? Actually, let's call it an input topic. Let's do that. And my input topic, if I can spell it, is going to be app.topic. I've got some data in weather data demo. That's a whole bunch of JSON that my writer in a previous video has been writing in. And while we're here, I'll create an output topic. And I'm just going to call it temp for now. We'll figure out what I'm actually going to call it before we put this into production. Then the shape of a stream processor is actually quite simple. What we're going to do is take that streaming data frame and apply some function to it, which will somehow transform each message. That call will give me a new streaming data frame. Then I'm going to take that streaming data frame and send it to my output topic. Like that. That call will give me another streaming data frame. And I'm going to keep making calls on my SDF to get a new kind of SDF until eventually I can call app.run on it. That is the shape of how you use a quick streaming application. With that in place, it just really falls to me to decide what this transform will be. So let's flesh that out. And I am going to call it transform for now, because I'm still figuring out what this should be. And the code for this should take the message, do something interesting with it, and come up with a new message derived from that. And then I'll stick in a logging debug line called returning that new message. And for now, I'm just going to return that. So this is the identity transform. This isn't actually doing any interesting work yet, but that's the shape of it. Should we run that? I think we should run that and see what that does and see if I've made any typing errors. So let's go down here, clear the screen, run it, see what we're dealing with. This very quickly has gone to my weather data demo topic. It's logged each message, and it should have shoved it onto an output topic called temp, if this is working correctly. So, previous video, I inspected this with KCat. This time I'm going to use a GUI just for a bit of variety. I've got the Red Panda UI running, and if I have a look on that, I have a topic called temp, and if I look inside it and start watching that topic, there we are. We've got messages coming in, exactly passed through. So, I mean, is that a stream processing app? It's kind of a stream ferrying, stream copying app, I guess. Let's make this more interesting. This is weather data. There is a key in there called current, and inside that there's temperature at an altitude of 2 meters. So let's do this. That's in Celsius, inside the message, under the key current, under the sub-key temperature 2 meters. And let's do this. Let's do some conversions. So Fahrenheit, which is not an easy thing for a European to spell, let me tell you. I looked this up recently. Danny Fahrenheit, he was an inventor, among other things, he was inventing thermometers to be sold on the home market. And nobody agreed what the scale should be. And he said, well, let's have 100 as body temperature, which he got roughly right. And 0 will be as cold as I can make ice if I add salt to it before I start freezing it. That will drop the freezing point. That was his scale. Fahrenheit goes from the freezing point of salty water to the human body temperature. And I did not know that. So there's a fact for you. Just for one more, let's throw in Kelvin. I've been reading Andy Weir novels recently, and they're really good, and they're set in space. So we'll have Kelvin, which is Celsius plus absolute zero. That looks about right. Those can form my new message. So I'm going to throw the Vim stick at this. Let's see. Let's have a regular expression. Very magic mode. Capture a number of word characters followed by the rest of the string. Replace it with that capture group, capture group, comma. Yeah, there we go. And then I just need to do braces around that and auto format it. And I've got a new message. Yeah, okay. Let's run that and see how that works. So I'll kill this one off, clear the screen, rerun it, and almost immediately, there we go. Naming things is hard, floating point numbers is still hard. I'm going to put some rounding on that, but I think we're basically done. So round that to 2 decimal places, round that to 2 decimal places, rerun it. How's that looking? It's looking good. Yeah, that's what I want. And let's just check the GUI as well. Rerun this. That looks good to me. Yep, okay. I just need to make this proper. Let's change that from temp to weather I18N. I've internationalized the weather for some of the world, the rest of the world, and all of space. That'll do. And I'll rename my transform function to internationalize weather. How about that? And with that, I think we're done, actually. I think that's the whole of a stream processing app. Register yourself with Kafka, define your input and output topics, define your transform, and then do some work to read, apply, and send, and off we go. And that's about it for the code. And I think we'll stop there. We could take this further. We could do a lot more fancy and interesting things with stream processing, and we will in future videos, I think. But it's worth stopping there and thinking what we've built, because it's simple, it's straightforward. No one's going to give you a keynote speech on the fact that we've transformed some JSON data. But it's actually really useful and important, the system we've built. Because if you think about it, we've now got a system where we can have a separate reader and a separate writer that may be 2 different departments, 2 different companies, maybe a fire hose of data from a third party being processed by a marketing department doing analytics. And there's so little they have to agree and coordinate on. The writer can be writing in one format of data, while the reader has a custom format that they want to read, and they didn't have to have an interdepartmental meeting to agree it. The writers can write at any speed they like. They can have bursty traffic, they can have busy periods, or they can be consistent. And it won't affect the reader. They can read at any speed they can manage. The reader can have an off day where maybe their system keeps crashing, and it won't stop the writer from writing new data. It will just sit there in Kafka until they're ready to catch up. Either side can go up and down for maintenance windows as they want without affecting the other party. There is so little coordination, it's completely decoupled. All they have to do is agree to write in a consistent format and be prepared to read in a different consistent format. And you've got 2 disparate departments communicating. And if you've ever worked in a large bank or any large company that starts behaving like lots of small companies, the ability to be able to do work independently and coordinate is just so valuable in IT. So while it isn't the most glamorous use of stream processing, in a way it is, because this is the one that decouples teams to get work done without having months of interdepartmental IT coordination meetings. And if you've ever sat in one of those, you know what I mean. So that's it for the code, and that's it for this video, and I'm quite pleased with how simple it is to make this happen. We'll put all the code on GitHub. If you liked this video and found it useful, please click like, and remember to subscribe for the next one, because next time we're going to do some fancy stream processing. But until then, thanks for watching.